thank you very much for attending this talk. I want to introduce also Francisco Monteverde, Kiko. He's our CEO of the company.
Thank you. Yeah, thank you very much for attending this talk. And I just don't see that much the lights, and I don't see the people. But I wanted to know if the people here use version control. How many people use version control? Yeah, most of them. How many are developers or coders? Yeah, a lot of them. And how many are artists and do games? So most of them, yeah. So they're coders. So a lot of coders.
People, doing the two of them.
Both of them. So that's great. So thank you very much. We love to talk to independent game developers, game artists, and we are doing it, a product that is for you. So, but let's give Manu and Ralf to talk about their experience in developing games with Plastic SCM. And at the end of the talk, we have a gift for all of you. So thank you very much, and we are there at the village, happy to talk to you and help you out with your games. Thanks.
Okay. Okay, so first of all, let's explain what Plastic SCM is. Plastic is the tool we develop at Cody Software, a very small company. We are how many we are? 10? 16? We are very small. And we are coders, we have one artist, and sales, support, and so on. We are very small, and we are very proud of developing this version control system, okay, which is called Plastic SCM. Plastic SCM is a new generation version control system. It's also distributed, that's why we wrote it DVCS, okay? And it's similar than other SCM tools. It has more capabilities than others, and I'm sure you know, well, how many of you know Plastic SCM before? No one? 2, 3? Oh, that's fine. And Subversion? Git? Okay. Mercurial? Perforce? Okay. So we are in the same business, okay? But ours is better, okay? I would say you later why. Okay, we have a lot of functionalities regarding games and distributed capabilities and so on. I will explain all of this in a few moments. So let's go ahead. Okay, this is the agenda. We are going to be covering all the points that explain what Plastic SCM can do for you. Okay, all the capabilities it has and how they can help you developing new games and new software. Okay. The first one, what do you can do with Plastic? You can do agile development. I'm not sure if you are aware of Scrum methodology. Are you aware of it? Do you use it? Okay, that's fine. So for those who don't know what Scrum is, it's an agile technique, okay? Consists in taking a group of tasks in the beginning of the sprint, and in iteration of 2 weeks or 3 weeks, you are in charge of finishing them, okay? So at the end of the 2 weeks or 3 weeks, you have something to deliver to the customer, okay? Your clients, or you have a new version of your game, wherever. The thing is that in 2 weeks, you have something you can touch and you can play, okay? So how we move Scrum to the version control system? Well, using, for example, a pattern that is called branch per task. Every time you have to perform a task, for example, creating a new artificial intelligence or improving the artificial intelligence. You create a branch, you develop your work in that branch, and then when it's finished, you merge it back to main, and you prepare a new release of your work. And in 2 or 3 weeks, you have something you can play with. Of course, if you are it allows you to work in parallel. If in your studio, there's a lot of people working, they can create their own branches, develop the task, and get them merged into main, okay? That's how internally we work, okay? And that's how other game studios are working right now with Plastic. Of course, your SCM tool, if you are going to be working agile, needs to have some capabilities in branching and merging. If you don't have the change of branch or merge, then you cannot do it, okay? For example, with Perforce, okay, it's very difficult to create branches or streams or whatever they call it, okay? It's some kind difficult stuff. With Git is easy too, okay? With Plastic is even easier, you will see later, and I would like to explain it also. The merging system is very easy in Plastic. The merge operation, sometimes the developers get scared, and the artists more scared, okay, when they get a merge operation. At the end of the day, it's something you have to resolve, and with Plastic, we think it's very easy to get them resolved, all the conflicts and all the branches, okay? So the second one, use a simple, Plastic SCM allows you to use a simple workflow. Why? Well, first of all, because Plastic SCM is very easy. We have a nice graphical user interface where you can review all your project history, the assets, the history of the assets, and create your own, create all the operations you can do with the SCM. We have a view in Plastic, which is called the Branch Explorer, which is this small view you have in black in there. That's called the Branch Explorer, and there you have all the branches of your repository display with all these little bubbles, the blue bubbles, which are the change sets. Every time you commit a change, you get a change set. And we display it in a very nice way in the Branch Explorer. So it's very easy to understand your evolution of the project using the Branch Explorer. And at the end of the day, the difficult operations are very easily done with Plastic, okay? You are not limited to clone your repository, create a stuff, and push it back. And if everything goes wrong, delete your local copy and clone it back and repeat the process, okay? With Plastic, you can take advantage of the version control system. And also, we have another graphical user interface, which is called Plastic Gluon. And we created basically because artists, okay, they hate version control system. At the end of the day, they don't like it at all. So we created this Plastic Gluon, which is a minimalistic graphical user interface that allows you to work on the assets you just need to be working with, okay? Imagine you have a working copy of 20 gigabytes, okay? With a regular SCM tool, you have to download the 20 gigabytes to your working copy and start working with that. With Plastic Gluon, you are allowed to grab only the assets you are interested in, start working on them, and commit them back to the repository. So instead of downloading 20 gigabytes, you are just downloading 5 megabytes. Okay, you are not forced to download the entire copy to your local drive. Okay, and as I said, we developed this for artists. It's very easy to use. It goes straight to the point, and you don't have these fancy features like subtracted merge, even regular merge, and so on, because we are very focused on working on the main branch and make the operation easy for the artist. Okay, Plastic SCM also allows you to improve your development in games. Why? Because, for example, we have a Unity plugin. You can work from Unity using all the, well, at least the most important operations that you can do with Plastic. You can create branches, you can view the Branch Explorer, you can check in, you can undo the checkout, you can undo the unchanged files, and so on. Everything from the Unity interface. You don't need to open Plastic. Later, Ralf is going to talk about how you can work without the Unity plugin. That's another option. But if you want to work with plugins, that's how you do it with Plastic and Unity. We are preparing also a plugin for the Unreal Engine 4. It's coming soon. Maybe in 1 month, more or less, we will have a beta for testing. Okay, it will be open. Also, we have big assets support. That means the repository is not aware of how big your files are. You can upload files, big files, and the repository is not going to be breaking. Okay. That's a huge problem in other SCM tools. For example, Git gets not corrupted, but it goes slow until the operations are completely unmanageable. Okay? With Plastic, you don't have that problem. You can upload all the data you have, no matter how big they are, and everything will be working fine. We don't have that that problem at all. It's funny because the old SCM tools like Subversion or, Subversion, CBS, they didn't have that problem at all. They are the new SCM tools like Git that are having this problem right now. Plastic is not having that problem either, okay? Also, we have images diff support. That means the artist can upload new revisions of PNGs, for example, and you can compare the changes between the two PNG files. You can see how a new color has changed, or if the face of the character has changed, you can see both of them. You can review side by side the differences, and it's really, really great. I don't have time now to explain it better, but we are going to be hanging around the stands, and we are completely open for a demo to show how it works. It's really awesome. Also, Plastic is very fast. That means the update operation, or creating branches, or reviewing the history of the file, the merge operation, they are very fast. No matter how the repository, how big is, the operation will keep very fast, okay? Yeah, and again, it's very easy to use. The regular GUI is easy for developers. The pro operations are made easy, and also it's very easy because we have Plastic Gluon for artists. You can go distributed with Plastic SCM. Remember, it's a DBCS. It means you can have your local Plastic SCM server with local repositories, and even if you go abroad and you are in trouble, you can continue working on your game and creating new branches, creating new changes, and everything will be stored in your repository, in your local one, not in the central, in the office one. That means you can, when you recover connectivity, you can push the content back to the central server in the office to share with your coworkers. Plastic also allows you to push, obviously, to external Plastic SCM server. So you can collaborate with other projects, not only the ones you are working on the office. And, we use the replication operation, which is basically pushing and pulling changes and branches. It's really similar than the Git pull and push methodology. You create local changes, and then you push to GitHub, Bitbucket, wherever. You do exactly the same with Plastic SCM. And finally, you can combine it with a central Plastic SCM server. Let me give you again the Git example. With Git, you only have your local server, and then you push to another server, another Git. With Plastic, you can combine the two methodologies. You can keep pushing and pulling information, or you can connect to a central server and do the check-in regular workflow. You connect to a central server, and you create branches on that server, and you perform check-in operations on that server. It's not needed to pull and push always, okay? And you can combine the two methodologies at the same time. Cloud Server, this is a really good feature we have just released. We have a Plastic SCM server on the cloud, which allows you to host Plastic SCM repositories. That means you can pull and push information to that Plastic SCM server. It's 24/7 available, of course, and you don't need IT for that server. We do it for you, okay? That's the good point. Basically, it's like a GitHub with Plastic SCM repositories, and you can use it. You can use it in two different ways. As I said, you can use it using the pull and push methodology, and also direct check-in using Gluon. You can commit objects, assets, files to the Plastic SCM server in the cloud using the direct check-in. You don't need to push and pull everything, okay? You can do continuous delivery and build with Plastic SCM. You can connect Plastic SCM, for example, with issue tracking systems. I'm sure you use any of these, Atlassian Jira, Mantis, Trello, I can't remember any of them. Well, we have a big bunch of issue tracking systems that are support. Okay. So you can go ahead and connect Plastic to one of those. You can also connect Plastic to continuous integration system. For building your game, for example, you can use Bamboo, you can use TeamCity, or if you want, you can connect Plastic with the Unity Cloud system, Unity Cloud build system. I will tell you in a second how. And it's very handy because you can connect your Plastic SCM server with any of these tools, and run scripts to run your tests, to run your games, run unitary tests, run smoke tests, etc. Okay? And if you want more, we have just released the Git server feature, the Plastic SCM Git server. That means, for now, with the latest release, all your Plastic SCM repositories will also be Git repositories, okay? The good point of this is that you can have people working with Git clients, running Git clones and Git push operations, again, a Plastic SCM repository, and at the same time, you can have Plastic SCM users using our Plastic Gluon or our regular Plastic GUI at the same time with the same repository. Okay? Now, Plastic SCM server can talk Git. In the background, it will be the same repository, but you can access in two different ways. One from Git, one from Plastic SCM. And this is very interesting because you can connect your Plastic SCM server with any other service that accepts Git repositories. For example, the Unity Cloud build. If you want to build your game that you have in Unity, you can target the Unity Cloud build to a Plastic SCM server, specifying the address of your Plastic SCM server, and we'll start building your Unity game. And it's very handy. For example, you can also connect any other tool you can imagine if they accept Git. It's very cool. And, well, here you have some big studios using Plastic SCM. We have, for example, Telltale Games, which are creating the Game of Thrones, The Walking Dead, and some other cool games. We have Face Punch Studios, which are behind Rust. We have Digital Legends, a very cool Spanish company. They are doing mobile games. We have Luminary Productions, Press Play, Codemasters. I have played thousands of hours of Codemasters games. But we also have small studios, independent studios. We have Stress Level Zero for Los Angeles. They are doing Hover Junkers virtual reality game. We have Cobalt Games. Ralf is going to explain how they use plastic inside Cobalt Games. And we, VR Unicorns, Yuli is hanging around also outside there. They are creating this cool selfie tennis video game. You can try it outside. And finally, VR Nerds. They are also showing up these Lucid Trip games outside. They are nominated this year, and they are all using plastic. I'm sure they can share with you how they use plastic, as Ralf is about to explain how they use in Cobalt games. And finally, I invite you to try Plastic SCM. We have a special offer for you. That means you can use plastic 2 months for free, up to 15 gigabytes, using the Plastic SCM Cloud. Okay, so you can upload your projects to the Plastic Cloud and give it a try. We are going to be hanging around the stands, so if you are interested in knowing more about plastic, we have a little book explaining all the operations in plastic, how to create your first project, how to add source code, how to start branching, how to start merging, and all the pro tips that are interesting to know. And also, if you have any question, we will more than happy to answer them and show plastic in live for you. Okay, we are going to be today and tomorrow right there for you to chat. Okay, so now it's time for Ralf. He's going to be explaining how they use for a long time Plastic SCM in their studio. So, Ralf?
Thank you.
Okay, it's your
Hello,
time.
everyone. Yeah, so now for my part, I talk about some applied examples where I think versioning shines, where versioning is ideal to use. But first, a bit about me and Cobalt Games, that you can match the later facts to this background. Then about the versioning, first our setup, then these use cases with some images, and finally some lessons learned, some points we learned these couple of years with this system. I'm Ralf, code wizard and treasure manager. It's an indie studio, so you do a lot of stuff. Also co-founder of the company Cobalt Games. It's a Swiss game development studios. We are 5 people, and we founded the company 12/12 in 2012. What we do? We do motivation design with games. So it's also called, for a couple of you that certainly know the term serious games, I more like this term, like this. We have some examples of our game. It's about nutrition, an extra game, sports game, where you have a lot to jump around, and also therapeutical games with really specific setups. You'll see that later on in the examples. I will bring up some examples of that. But now, we're here to talk about versioning. So, our setup first. We have an in-house server, Plastic SCM, on an Ubuntu server, and the database are MySQL databases. And for us, it's important to have LAN access because of the huge repos. The repositories, we put the whole game and all the stuff in it, so it's really, for us, it's really important to have a fast access. There's the point, what is versioned? We version the whole project, not only the game itself, it's the whole project also with non-game related stuff like invoices or concept stuff, and so we have each project one repository. We have also a specific repository for our core framework that is integrated into each project repository. We'll see an example of that later on. And then we have called company repo. There is all the stuff that's not project related. That's some accounting stuff and things like that. For us, it's really cool to have this all in Plastic because we can just make a backup of our MySQL database and we have backed everything we have in the company. So that's really easy and really handy, not scattered around stuff anywhere. Then who uses it at Cobalt Games? It's every teammate from the audio to the graphic designers and even the customers. We gave them some of the customers read access from the idea that they can pull new versions directly there. So we don't have to go through the whole distribution with building, zipping, and do the stuff like that. And we also have customers that continue development and they use the source anyhow, so it's really easy to collaborate with them. Now, to the core of the presentation, some use cases where I think, or we think as Cobalt Games, versioning is really great to use. These are things that, because of these things, I don't want to work without versioning anymore. You can call it like that. I gave them some names. It's at the customer, the first one. Imagine the setup. You have your office, the project in the cloud or on your server, wherever you have it, and the customer. In this example, the customer has a really specific setup, and for us, we develop at our office the game for them. It's committed to the server, and then when we go to the customer with a version is done, we can pull it from the repo to their setup, and then do some debugging, development, changes there to manage to build it to their specific environment. And then when it's done at the customer, I can push the changes to the server, and next day at the office, I've got every change. And if I worked a bit documented at the customer, the check-ins are well documented, I also have everything I need for a report, for invoices or whatever you use, or for the own tracking system. You know what you have done, really easy to see within the system. The second use case I called fast collaboration. Probably the easiest one. But I don't like to work without it in a team anymore. So setup, you have an animator, programmer, and then the animator says, oh, I have this animation where my wizard swings the wand, and exactly at the point where the wand is in front, I'd like to call an effect, a sparkles effect or something like that. I need this event trigger. Can you program this for me? the programmer creates the event, pushes it, the animator can fetch this and start integrating it. He doesn't have to file copy anything or zip or a file together on Dropbox, see for the newest file, just pull and work with it. You don't even have to know where the changes were made. So this is really fast, also in the team, also if you're in the same room, to work together. Then certainly the case coding within the same file. Imagine the setup, you have released your beta version, a lot of customer feedback, usually a huge list of bugs as it is, and then you say, hey, before we continue, we fix the bugs first. So we have this huge list, and the two programmers here in the image start to fix these bugs. So if bug 1 and 2 are in the same file to fix, you don't have really to talk to each other. You can just start fixing the bugs, and you see in the same file, changes are made, they are committed, and then you have your merge tool, and for programming code there, in most of the cases, for me, the automatic merge does well. So you can just see, this code up here, code down here, well done, go on. So no copy of lines or merging files together, or do you use this file? Oh, wait, I have to, and stuff like that doesn't exist. Next use case is compare solutions. You have this project, and you have several ideas what would make that project better. So you have this idea, I would have to have this dark setting with clouds and always raining, and you can do that and experiment with that on a branch. And then you have this idea, it would be great with rainbows and unicorns and stuff, and you could make this on another branch, and always can switch between these two branches to see the versions, also develop them further and test like that. And finally, you can decide, I take this project to continue, but this idea with this nice little unicorn, I want exactly this one within my project too. So it's, you called it before, it's called cherry picking. You can pick one feature, one stuff from other branch and integrate it to continue. So it's the comparison of different versions, and you don't lose anything of it. So the files are all there. You can go back to these ideas and fetch things even later on. And the last one, it's probably the most complicated, but I think it's really important to know that this works. It's managing a core framework. And the setup here is you have your core in the middle, and there is it's your state machine, it's your backbone of the game. You develop this, some helper classes, stuff that you really use in every game. And then you have project A and project B, and there you see the core is integrated. What this is, these are three repositories, project A, project P, and the core itself is its own repository. So if I continue working on project B and we say, I also develop better stuff at the core. You see another circle around, core is now better, then the core repository gets automatically updated. Then I'll continue on working on project A, and I decide, no, but the core isn't stable enough. I'll continue working with my core I've got from previous versions. Then you develop again on project B, and you really make this core shiny and well, and everything fits. Then you can decide, now I'll update the core in project A, and you can use this stuff in there and update this. So you don't have to copy these files from project to project, because the core, the base of the game you use everywhere, is versioned in a repo itself. And this is also for me really great for us also with different little projects, working parallel on different projects, to have something that supports this management. Now, some short lessons learned. I think this is always good. I've heard this, probably most of the things you have to try yourself or walk into trap yourself. That's normal, but if you heard it once, probably it's gonna help. So even the system takes care of much of things. It's really important to name your commits, your labels, stuff like that. Make good use of this. Decide in front, if you see how it works, how do we do it in our team? Because even you can go back a year in a project where you want to look for a certain thing if you don't named it or described it there. So use this on the way, ongoing, the things. Then, important for me to say, we started with Dropbox first. We versioned our games with Dropbox first, worked together there. It works, but I would never use it anymore. So it's, for us, really important is about the size and the speed. If you have a 30 gigabyte repo with your game in it, and no way you can do that with Dropbox. Doesn't work anymore. So decide which tool for you is the best and which are the features of the tool you want to use, which best for you. Then, as he told already, with Unity integration, we tried with Unity integration. For us, we don't like to use it, the integration, because we version all the projects. So we have documents, PDFs, Photoshop files, everything in the same repo. So we would need for every tool an integration that we could not use the main tool. But this doesn't make sense. Then you have 10 different integration tools with different UIs. It's a mess. So we use the core framework for everything. And also for us, Unity gets less crowded. We have our own plugins, our own UI extensions in Unity. So another one it gets too crowded. Then the last one, be careful with your write access to your repos. If you decide to generate new users and groups and stuff, you can remove your own rights to your repos, and they're gone. So lucky enough, I had direct database access, and I could, the binary codes for the rights, I could change them there back, but it happens. Questions?
Thank you very much. Thank you.